Hi, my name's Harry, and I've figured out a way of using this WiiMote to unlock my house. Let's talk about that. Right, we're losing sunlight by the minute here, so we need to make this quick. As you can see here, door won't open. I press A, 1, 2, B, door opens. So as you've now seen, it's not clickbait. I was actually stupid enough to try and figure out how to do this. Why did I do this? I can't tell you that. I simply don't know. But I can show you how I did it, and that's what we're going to get into right now. So the main component for this entire project is an ESP32 microcontroller. Not really anything special, just a very generic one, and it's going to be used to put all our code on and control everything else that happens. Now, if you've got any kind of resemblance of a life, you definitely don't know what an ESP32 is. It's a type of Arduino, which is a type of small computer that you can basically use to build whatever you want. But this type specifically is used for wireless communication like Wi-Fi and Bluetooth, which is what I'm going to be using to talk to the WiiMote. To physically unlock the door, we need a little servo like this one, which is just a motor that we're going to attach to a bit of a metal pole that will turn the lock on the door. These things are also incredibly cheap, and it should just be powerful enough for us to be able to turn the lock. So, just to pause the video here for a second, I did manage to get this key to turn a key in the door that you saw earlier in the video. However, I wouldn't recommend this for turning an actual key. In retrospect, it would have worked much better to push a lock like the one you can see now, because it would just require so much less force. I ended up having to tape this entire mechanism to the door in such a disgraceful manner that I couldn't even keep it in the video. So in summary, I would only recommend this motor for small locks that slide very easily. And if you don't care and you want to do this anyway, here's a very small clip of the motor actually turning a key while it's just resting on a chair, so you have some kind of idea what you're looking for. Though again, I do not recommend this, it will only bring you pain. Here's a short clip of the metal pole that will be needed to attach to the servo. The pole itself is really bendy, so it's really malleable, I guess is the word I'm looking for. You can kind of just force it to be in whatever shape you want, while still being sturdy enough to not be bent by the servo itself when it turns the lock. Actually assembling this stuff together is much easier than you might think. The servo only has these 3 pins in them, so you need to put male ends of 3 wires into those holes. Ideally, try and use the same colour wires that are on the other end of the servo, just because it'll make it easier for you to follow them later on. So the other ends of these cables connect to our main board. The red wire goes to a power supply, so I've used a 5 volt on the end of my board. The brown wire is a ground pin, so that can just go to any of the ground pins. But I use the one next to G18 because that's where I'm plugging in my data wire, which is the last one available. And at this point, nothing else needs to be assembled. We can just move on to coding the actual software for this. Now, if you want to follow along with this, which I do not recommend, I have put a link in the description to the GitHub with all the code on it, so you can just copy and paste everything that I did. That's completely fine. Now, I myself am an absolutely terrible coder, so if you feel like you can make this code better, then definitely go for it. Let everyone know in the comments. Tell them every single place that I went wrong, please. It would be very much appreciated. The very first step is to download the 2 zip files that you can find in the description. They include libraries that we need to install into the Arduino IDE. Also, you may need to install the drivers for your specific operating system on the page you can see here. Go to Sketch, Add Library, Add Zip Library, and install both of those zip folders that we just downloaded from the GitHub pages. From there, you need to go into the Sketch tab and go to Board Manager, and then search for ESP32 and install the 2 that you can see I've already installed here. And as you just saw in that screenshot, your board should show up somewhere in that list in the drop down menu. Now, if you actually want to use this code, I would recommend just going to the GitHub in the description and downloading it, copy and paste it, whatever, because what you're about to see here that I'm going to try and explain through is me trying to remember it all off the top of my head for this tutorial. So yeah, if you actually want to use this, I would recommend going to the GitHub. So what you're seeing here is me including the library for the ESP32 WiiRemote connection, and then again for the ESP32 server control. And you may already have these in your code if you included the libraries automatically, but I didn't when writing this, so I just typed them out. The very first thing that needs to be done is to set up an instance of both the WiiRemote and the servo control. Now what you can see here is me setting the actual password. So this is what I'm going to input into the WiiRemote by pushing the buttons, which will unlock the door. So if you want your password to be something different to mine, then you can just change this. So let's say you wanted it to start with the B button. Where I've written button A here, you would just write button B, comma, space, and then your next input. So this next line defines the current step, which is going to allow the program to know if you've entered the right step of the password as you're putting it in with the WiiRemote. Here I'm just connecting to the serial monitor, which will allow us to see in like a console view of the IDE what's actually happening as the code's running. Now, if later on you can't see anything appearing in the console when you think it should be, you need to make sure that you have that same number that we just typed out set in the console. Here we're just making sure that every time the program runs, we have the ability to connect to the WiiRemote and that part of the code starts running. Now here I'm telling the program what pin I have plugged the servo into on the main ESP32 board. I realize here that I've referenced a variable that doesn't exist, so where I've written servo pin here, you would just write 18 or whichever number pin you put the servo into when we set it up earlier. Then we're setting the position of the servo to 0 as soon as the program runs. You don't actually need this next line, it's just a way of printing to the console that the program has begun. Begun. So here we're finally starting to say what we want to happen when we actually press buttons on the WiiRemote. So we're going to start off with this if statement that basically just says, whenever the WiiRemote is available and we're connected to it, do this. So in this example you're seeing here, we are basically making it so that when we press button A on the WiiRemote, the console knows to print the letter A. So here you can see I've just pasted in all of the other ones. So this is how you would add them for every other button. Now you only actually need them for the buttons that you're using, bear in mind. This lock door function that you're seeing here, we're going to use later in the code. This is going to be a way of locking the door again very easily once it's already been unlocked by the password. Now in this example specifically, I'm making it so that when button A and B are pressed at the same time, the door locks. Obviously, if you want it to be something different, you can change that here. I'm only going to add the next print lines for the buttons that I'm actually using in both the lock door and the password, because I don't really need the rest, so it's just kind of a waste of time typing them out. But obviously if you have different combinations of buttons, you would put them here so that they show up in the console when you press them. I also made an error here where I put underscores just out of habit. Just ignore that, we don't need those, they'll break the code. This next if statement is really simple. It's basically just saying if the correct button in the sequence is pressed, then print to console you've pressed the correct button, and after that increment the sequence by 1 so that the program knows that we're on the next character of the password. So in this next if statement, we're saying if the current step ever reaches 4, then that means that the password is complete and it's all been entered correctly. If that is the case, we're telling it to print the line, welcome, you've put the password in correct. Of course, if your password is longer than 4, you'll have to set this stage of the code to be like however many your length is. Then of course we need to actually open the door, so myservo.write, and then I've done 180, but you'll need to mess with this a lot, which I also had to do, to make it turn the right amount to turn your lock. Then the current step is set back to 0 to reset the whole sequence. Then this next part's just saying if lock door, which is before when we said press A and B together, then just set the servo back to the locked position, which here I've set as 0, but again you'll need to make sure that that actually works for your door. Then here we're finally getting around to telling the code what to do if the incorrect button is pressed in the sequence. When I actually came to run this, I had this error where the serial monitor was just spamming the same error message over and over again. I eventually came to realise that we just needed to add a filter to the code to ignore all the accelerometer data, so you know, like when you turn the Wii remote, we don't want that data, so we just need to ignore it. Something really important that I almost forgot to mention here is to pair the Wii remote to the ESP32 once the program's running, you need to hold down 1 and 2 while the lights flash, and then eventually it will pair. At this point, once you've plugged in the ESP32 to your computer and uploaded all the code, putting in your password with the Wii remote turns the servo one way, and using the door lock turns it the other way. Now for a very frustrating part that's going to be very unique to your door specifically. You need to tie that piece of metal around the servo and then also around whatever your lock is. As I mentioned earlier, I got this working, but it was extremely messy. I had literally sellotape doubled back on itself to hold the ESP up to the door. Again, it would work much better on a little sliding lock instead of a key, but it can work if you persist with it. Also, if I were to do this again, I'd probably say that adding some kind of beep or just any kind of recognition that the door was unlocked would be pretty good too. But aside from that, I'm pretty happy with how this turned out. So that's it. Who needs keys when you've got a perfectly good Wii remote just lying around your house? I'm telling you, throw away all your keys, throw them away. This is the future. Thanks for watching. Out a way of using this Wii remote. And I've figured out a way of using this Wii remote.